Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to machine a Vise tool caddy. I suspect that most of you that watch this channel also watch Chuck Bommarino over on the Outside Screwball channel, and Chuck has done a couple of videos on 3D printing tool caddies for his vise. As I've said before on this channel, 3D printing so far is something that just hasn't tickled my fancy. So we're going to do it the old-fashioned way today and machinist one out of a piece of aluminum block. Now, not this whole piece. This is a piece of material that was in a lot of stuff that I picked up recently, included some tools, a lot of aluminum, some steel rod, channel iron, so forth. This was part of a fixture plate in a manufacturing facility, and I've cut pieces off of it before and used for other projects. Today we're going to take this corner out right down here. That'll give us about a 4-inch by 5-inch block, 3/4 inch thick. Actually, yeah, there'll be three holes we need to plug in it, but we'll get to that a little bit later. What we're going to use to cut this out, obviously I could go to either of my bandsaws. I've got the horizontal vertical bandsaw, and I've got the bandsaw that is the portable bandsaw that I put on the upright stand. But I think what we're going to do is use this slitting saw arbor that we created in the last video, that we machined in the last video. It'll be a whole lot faster than the either of the band saws, and it'll give us opportunity to, or give me an opportunity to show you guys this tool in progress or in use. So I'm going to turn over to the mill now and get set up, and we'll cut our block out of this plate of aluminum. Now, in that material that I picked up, there was several 1-inch thick pieces. There were some 2-inch thick pieces. Something a whole lot cleaner than this piece. But right now I'm still a little bit uncertain of just how useful this the caddy will be sitting on the mill. I think it'll be a useful addition here to the Tin Barn, but I don't really want to use any of that other material just yet. I'd rather just try it out of this piece, and like I say, there's a few holes in here we'll need to plug. But I've got the plate mounted in the mill vise now, and this quadrant down here is what we actually are wanting to cut out. In the last video where I made this long reach arbor, my issue with the regular arbor was the diameter up here. On the spindle, collet holder on the spindle, prevented me from getting full depth on the slitting saw. So we're going to attempt to make a full 3/4 inch pass all the way, or 3/4 inch cut all the way to clear our block. And we're going to come out here. I probably won't go the full length. I'll just get past our line for the other axis. So let's come over here. I'm going to try a little bit slower RPM to begin with, and I think I want to get my coolant going on this, because it's cutting aluminum, but it's still going to be a pretty detailed cut. Let me stop that from turning while my fingers is over here close trying to get this set up. And we'll just want to keep some coolant flowing on this. We don't necessarily have to have it flooded. And that's going to splash all over me. I got my shower curtain up in the back over here. I've got the depth set to where about the top edge of this slit that's already in here. Oh, I'm sorry, the bottom edge of this slit that's already in here. I'm going to turn that coolant off until the blade gets in there. I'm getting a shower. Right now I'm just getting the depth, the depth set on the saw. All right, I'll lock the y-axis down now. And let's start feeding in a little. Okay, it's in one of those void areas in the piece. We'll let it pass on into that, and we need to cut into the solid just a little bit more. But I'm really pleased with the way this this long reach slitting saw arbor is working. All right, that's cut deep enough on this axis. We'll take the piece off, out. You see we made that cut all the way through in one pass. So now we want to turn it up. And we've got just a shortcut to make over here. We'll go through this void right here and cut in to the saw cut that we made on the other axis. All right, saw blade is coming all the way through. All right, I am going to carry it over to the bandsaw to finish these little corners right down in here. Then we'll come back and we're going to actually square this piece off. We'll go through the process of squaring the piece. All right, here's our block that we're going to be using for the tool caddy that we'll set right up here. This will be milled out in here. But we need to square this piece up. There's not a factory edge on any of the four sides. But you guys bear with me now, because we're going to get to actually making the tool caddy in a little bit. But when you're in a hobby shop, a lot of times your raw material is recycled material, and that's exactly what this is. So we're going to start out with what looks to me like the straightest cut on one edge. And this saw cut right here, or this cut on this side, was actually one of those situations where I had to make a pass with the slitting saw on this side and then a pass on the back side. And so we got a little unevenness here, but pass or two and we should be able to get it all out. That's the 0 on the Z-axis DRO. As I said earlier, we've got 3 holes in here we've got to deal with. I'm going to take the end mill out now and get the drill chuck in, and we'll take care of these holes. Two of these holes that we've got to deal with now look like 1/4-inch holes. They're threaded 1/4-20, and this one looks like a 5/16. We're going to make them all 3/8. I'm going to drill them out with a 21/64 bit, which is a 64th less than a 3/8. Then we're going to ream it with a 3/8 minus 1/1000 reamer, chucking reamer. And then we're going to cut off some short pieces of this 3/8 inch stock and go to the hydraulic press and press them in. Alright, we've got our pins pressed in now. Most of this top of this surface here is going to be milled out, so I'm not worried about this finish right here. After we get it all milled out for the pocket over here, we'll probably run the fly cutter over it just to clean everything up. The bottom side there's a little bit of taper there where I chamfered the plugs. Most of that is going to go away as well when we're going to mill a slot in the bottom side that will just fit over this. But for now, let's find the center on the x-axis on this piece. Zero out the x-axis. Now, x 1/2. Alright, there's our halfway on the x-axis. So let's take the drill chuck out now. And I've got 0 set in this location, so let's come on out here where we got some room. And we're going to be using a 1/2 inch end mill. Alright, our vise jaw is 4.122 inches. I suspect that's probably a nominal metric value, but 4.122 divided by 2 is 2.061. That we need to move over it. Plus we need to move over 2.061 minus half the width of the end mill, which is the end mill's 500, so 250 off of that is 1.811 we need to move over. I'm going to move over 1.805 to start with. We can test it. If it doesn't fit, we can set it right back in here and shave a little bit off the edges. There's 1.807. I'm sorry, 1.806. So we'll try that. And we want to touch off right here and 0 out the z-axis. We're going to take 1/8 of an inch out. Remember, this is 3/4 of an inch thick. So we're going to go 1/8 out to slide over. We'll leave 1/8 thickness for the bottom of the caddy, and that'll leave us a 3/8 inch cavity inside to hold our tools. So let's come down 125 thousandths. Since this is aluminum, Looks like we got a pretty sharp end mill, so we'll try all that at one time. I'm going to keep a little WD-40 on it just to, again, just to keep the end mill from clogging up. Now we should be able to come to 1.807 on the other side. I'm going to do a little sanity check here. That's a little bit looser than what I was hoping for. We're going to go ahead and cut that. Take it out and see how that fits. Yes, that's just a little wider than I had planned or had hoped for, but we're going to go with it now. So let's mill all this out. All right, I think that's all right. It's, like I say, it's about 5 thousandths wider than I had planned, but I think that'll be fine now. All right, I'm gonna, again, carry this over there to the other side of the, what I call the dirty side of the tin barn, and deburr these edges. Come right back, and we'll mill out the pocket. All right, for the top side, and again, the pocket is going to be 3/8 of an inch deep. We're going to probably do that in 3 passes or in 3 depths. I've got a 1/2 inch laid off on each side, and I've got my coordinates noted with 0, 0 being back here. We'll need to come over 3.8 inches to touch this line. From 0 here, 2.4 to touch that line. I'm staying about 25 thousandths off to begin with. I've already got my Z-axis set to 0, so let's try plunging 125 thousandths. Just want to be sure my calculations are right. Yeah, that's off the line a little bit. All right, I'm going to go down another 125 thousandths, complete this process, or complete the same process again. Then we'll go down to final 125 thousandths, and I'll bring you back for that. All right, we got us a, a 1/2 inch deep pocket now. We're going to go down another 125 thousandths to be a 3/8 pocket. First thing I'm going to do now, though, is go around the perimeter. I'm at 0, 0 now. And I'm going to come to my dimension over here, which was 2.4. And I'll come over here, which was 3.8. Back up to here. Back up to 0 on this axis. And back to 0 over there. We'll have our outside border cleaned up then. Outside wall. And then we'll hog out the inside. So we want to come down 375 thousandths. Both axes are locked right now. All right, there's 375 thousandths. We'll unlock the Y come to 2.4 on the DRO. Now we'll unlock the X and come to 3.8 on the DRO. Lock the X, unlock the Y, come back to 0 on the Y. Lock the Y, come back to 0 on the X. Alright, all that's left now is to hog out that in the middle. Let me clean that out. As you can see, we got a good clean wall over here. Same thing on the other sides. So I'll hog out the rest of this in the middle right here and bring you right back for a recap. Alright, I've got the inside hogged out now. We've got our pocket. I did make one more pass on this side. I looked up on the large screen monitor that I use when I'm recording and saw that there was some still some indications in there, witness marks of where I'd eased up to that edge and hadn't quite cleaned up. So clean that up. We're going to take the fly cutter now and make one pass across it just to clean this top up, clean any marks up, and after I do that, I'll carry it over to the again over to the Scotch-Brite wheel, clean up any burrs that might be left. Then we'll come back and do a quick recap. Now, I've already got the 0 set on the Z-axis. I'm just going to come down about 5 thousandths. I'm not looking at taking much off here, just to clean it up. Okay, what I do need to do though, I need to come back and I need to do that a whole lot slower than what I'm doing now. Let's come down. Let's come down to about 7 thousandths. And we'll slow that feed way down. Probably when you see this in the video, when you see it speed up in the video, it'll be at about 8x then. Yeah, that's leaving a much better finish now. So I'll speed it up here in just a second on the video. Alright, that's got it fly cutting done. Like I say, I'm going to take this off, get it in there and deburr it, and then again we'll come back for a real quick recap. Alright folks, here's the finished product. We milled out 1/8 of an inch under the bottom to give us a lip to set over. Then we milled out 3/8 of an inch inside, which left this bottom 1/8 thick. Left a border around it. You know, I hope this turns out to be a useful addition to the meal, but I'm so used to just picking up my brush and brushing the chips off this area, and even using this pad to write dimensions down on. So it's yet to be seen how much use I'll get out of this, or if it gets in the way. If it turns out to be useful but has limitations because of the depth, I'll consider using some of that other material that's a little bit thicker. to make a different one. But in any case, I think the process will be the same no matter what I did. Hope you've enjoyed this little mill work here in the tin barn, and we'll see you on the next video.